Hi, this video is part of a series of misconception videos on ratios and proportions. In this video, we will talk about a common misconception that students have in cross multiplication of terms of equivalent ratios. Here's a sample question to illustrate this misconception. It states that if 7 is to 10 is equal to 21 is to 30, which of the following is also true? Option A states that 7 into 30 is equal to 10 into 21. Option B says that 7 into 21 is equal to 10 into 30. Let's see some data on this question. Out of a total number of students, which is 2095, 76% are choosing option A, while 24% chose option B. So since 24% students answered it incorrectly, it seems that there is a prevalent conceptual gap when students answer questions like these in lower grades. However, let's also look whether this misconception continues in higher grades or not. Here's a sample question from a higher grade. So in this similar question, it states that if J is to K as L is to M, which of the following would hold true? Option A says that J into L is equal to K into M. Option B says that J into M is equal to K into L. Option C says that J into K is equal to L into M. And option D says that J into K is equal to J into L. Here too, many students answer the question incorrectly, getting confused between the various options. We can conclude that there is a lack of understanding when students apply multiplication in questions based on proportionality. So where do students go wrong? How exactly does this misconception arise? Some students have the notion that multiplying first and second terms of two ratios is correct. So if A is to B as C is to D, then A into C is equal to B into D. Some students also make mistakes because they are used to terms of an equation in fractions and the ratio notation is unfamiliar to them. Since the misconception is also there in higher grades, it is obvious that students are also not clear on the properties of equivalent ratios. So how do we remediate this? Some possible ways are to represent proportional situations more clearly. We can represent the ratios in fraction form so that students are more familiar with the multiplication process. In cases where we showcase proportionality between ratios, we can equate the terms using constants. Using constant like k is a very handy way of making students know that we are in fact using equivalent ratios. We can also use simple examples with actual numbers so that the concept is not too abstract for students, and they can see for themselves why some methods of solving multiplicative questions on ratios would be wrong. For example, in one case, we could say that 3 is to 4 as 6 is to 8. So 3 into 8 is equal to 6 into 4, and 24 is equal to 24. So other cases of multiplication would be wrong. Thank you for watching this video. I hope it helped.